Many people consider the de-alerting of nuclear weapons to be a positive step towards reducing the likelihood of nuclear war. However, despite its advantages, many fail to address the inherent issues that prevent this concept from becoming a reality. Let's consider the practicality of de-alerting the various parts of the nuclear triad. Bombers can be de-alerted by keeping them unfueled and keeping their weapons locked inside nearby weapon storage facilities. This is something an adversary could verify using near real-time surveillance satellites. Requiring aircraft to be both fueled and armed before takeoff would take many hours and be readily detectable to an adversary. Silo-based ICBMs can be de-alerted by placing large heavy objects over their lids. To remove all of the objects may take days. Mobile ICBMs could have their warheads removed to be stored in secure facilities at their bases, again possibly requiring days for all warheads to be reinstalled. Again, both of these could be verified by near real-time satellite imagery. Submarine-based missiles could be de-alerted by keeping submarines in port unloaded with their missile tube lids open to be verified by near real-time satellite imagery. They could also be deployed at sea with ballasts installed along with the MIRV warheads of the missiles to reduce their range, and patrol outside the ranges of the missiles to be verified by broadcasting their approximate location at regular intervals. The problem with all of these de-alerting techniques is that they significantly degrade the survivability of the deterrent force. Even if we assume that both sides trust each other enough to de-alert their forces, if one side becomes suspicious of the other side's activities, it will try to re-alert its forces in response, creating an incentive for the other side to re-alert its own forces. This creates a dangerous race to alert where the chance of unintentional nuclear war is significantly increased. For de-alerting to be sustainable, both sides must be confident that their ability to respond to an attack will remain intact. This is not possible with full de-alerting, so a proportion of the nuclear forces will remain on high alert. For example, land-based ICBMs in a state of possible high alert, and submarines with unknown positions at sea cannot possibly be verified as on or off alert. This raises another point, that reducing the alert rate of a system does not necessarily increase decision time. Let's consider a silo-based ICBM partially de-alerted to a 14-minute alert rate versus a 4-minute alert rate, where alert rate is the time taken from the order being given to the missile being launched, allowing 1 minute for the missile to fly far enough away from its silo to survive an attack. We will assume the attack is from an enemy ICBM with a time of flight of 30 minutes, where it takes 10 minutes from missile launch to detect the launch, gather satellite and radar information, and relay the information to the head of state. For the 14-minute alert rate, the missile must be launched no later than 15 minutes before the projected time of impact for the missile to survive, giving 30 minutes minus 10 minutes minus 15 minutes equals 5 minutes decision time. For the 4-minute alert rate, the missile must be launched no later than 5 minutes before the projected time of impact for the missile to survive, giving 30 minutes minus 10 minutes minus 5 minutes equals 15 minutes decision time. Ultimately, the only way to remove the incentive for either side to be pressured into making a quick decision of whether or not they should launch a response to an unconfirmed attack is to make their deterrent force as survivable as possible. Therefore, it doesn't matter what the alert rate is, or if they launch a response before an attack arrives or after the attack has taken place. As long as there are sufficient checks and balances in place to prevent a wrongful launch order, and that the launch procedure contains sufficient order verification, nuclear weapons on high alert do not necessarily pose a significant risk.